Well, today's lesson is called Solving Problems Involving the Zeros of Quadratic Functions. That may or may not scare you. But as soon as the question starts for the example, that might scare you. Because as soon as you start reading it, you're like, oh, here we go. Word problems. This is not my strength. But I'm going to give you some strategies. I don't know how much math I'm teaching today. I'm teaching strategies for word problems. That's what I'm going to focus on. I don't know if I'm talking to you, I'm more talking to me. Make sure you give them some strategies, some ideas. How do I do a word problem when I read this? Because most people on this planet, these are the type of word problems that they make fun of. If you're watching a TV show where they're making fun of math, this is the exact problem they make fun of. One's just like this. Shh. The sum of the squares of two consecutive even integers is 452. Find the integers. For a lot of people, by the time they finish reading that, they're like, well, this is what I don't like about math right here. How am I supposed to know what to do? Strategy 1. My gift to you, an early Christmas gift. After reading that, you're like, whoa, write this down. Let x equals. And you think that's not a big deal, but it is. It's a start on this and go, what am I looking for here? After you write let x equals, then reread the problem and go, what am I trying to find out here? Forget all the details. Forget all the fancy words. What do I want to know? What am I trying to figure out? What does my answer look like? It says the sum of the squares of two consecutive even integers is 452. Find the integers. So the second time you read it, just underline, what am I trying to find out? Things will get better. So those are your two strategies to start off with. Write down let x equals, and then reread the word problem. Don't get hung up in the details. Just look, what am I trying to find out? And I'm trying to find out the integers, the two integers. Well, that tells me what to write for let x equals. Let x equal the first integer. Now, a bunch of things happen once you write that, hopefully. The first thing that happens is you start building some confidence and you go, well, word problems are tough. But maybe I can do this. I already know what I'm looking for here, and I've already assigned it a variable. I've already got x involved. The second thing that happens is you've got a weapon to read the question with now. You go, okay, x is the first integer. Is there some information about the second integer? Let's read it. The sum of the squares of two consecutive even integers. Now, I've underlined that differently. You don't have to underline it differently. But I'm underlining it differently to going, this was the next stage in my reading of the question. I'm just pulling the question apart piece by piece and going, oh, two consecutive even integers. So I need another let statement for the second integer. Now, I'm going to make a word problem mistake here. This is the mistake people make in word problems. But I'm going to write it down. And unlike other times where I told you not to copy down my mistake, I want you to copy down my mistake. I want you to write down exactly what I write down, and then we'll fix it, because that fixing is the important part of this question. I'm going to write let y equal the second integer. It's a bad mistake for word problems to let one thing equal x and then let the other thing equal y. But your brain tells you to do that. Your brain says, yeah, let y equals. But I've introduced another variable there. What I'd like to do is change that, and I'll change it in red, and go, okay, I want to represent the second integer, but I don't want to use a new letter. I want to use what I know about the old letter. Thought bubble. Here's some powerful stuff. Those of you who are like, I don't care what you say. I'm enjoying your class, Mr. Taub, but I don't care what you say about word problems. I'll never be good at them. You better check out the thought bubble for a second, because I have a plan. My plan is not to get caught up in the x's and just to think about numbers for a second. I'm just preloading an elastic into my hand here. Thought bubble mathematics. I'm speaking specifically to those of you out there like, I don't care what he says. I can never do word problems. I'm like, just come over here for a second, and let's just talk about these integers. Let's just pretend. And you get to just make up a number. I'm just going to go over here and I'm going to make up the first number. This is a powerful strategy, by the way. Like, you just make up any number? Yep. Just a little thinking over here and going, I'm going to make up a number. I'm going to choose 52. If 52 was the first number, which it's not, didn't want to accidentally put the right answer up there. 52 is not the right answer. But if 52 was the first integer, what's the second one? See? No x's, no complete the square, no quadratics, no variables, nothing. Just do we understand what the question's asking? If 52 is the first one, what's the second one? It says 2 consecutive even integers. What's the next one? Is it that hard? Or are you just shy? Who's being shy? Oh, she's looking at this going, is it 400? Okay, let me just focus on this. It could be 400. Yeah, but right here this says 2 consecutive even integers. 2 consecutive even integers. So my first one's 52. What's the next even integer? 54. There's the thought bubble mathematics. You're like, let's just talk about 2 consecutive even integers. Now, here might be the hard part because you're going to think it's so easy, you're going to think I'm ridiculous. How did he get 54 from 52? What did he do to the 52 mathematically? This is the hard part, is to go mathematically what did he do? Because some people are like, well, it's 52, it's 54. Yeah, I know. But if we're going to get back over here to the variables, we've got to mathematically understand what he did to get from 52 to 54. What did you mathematically do to get from 52? Added 2. I'm just going to make that note down here. And again, for those of you who are, I'm never going to be able to do word problems, just come back over here for a second. Just thinking about numbers, I went, if 52 is an even integer, the next consecutive even one was 54. That's why I had to add 2, because it was even. So this second integer is x plus 2. That is a major league victory. That's the problem you're probably having with word problems, is getting that far. So those let statements, I think sometimes it doesn't get given enough weight in earlier grades. We act like the let statements are like good communication, good form. And I go, I don't care about your communication or form here at this moment in the lesson. I care that you thought this through and went, what are the 2 integers? If x is the first one, the next one is x plus 2 because they're consecutive even integers. Some people can just do that. The algebra just speaks to them, and they just go x plus 2, good, I'm on my way. But for most people, that's the problem there. And I suggest going over here and just going, let's just do it with numbers for a second. Let's not do it with x's. What would the 2 numbers be? 52, 54, or 48, 50, or 102, 104. What's happening? I'm adding 2, so that's x plus 2. All right. How many strategies have I given you so far? First strategy, when you get a word problem, write a let statement. Second strategy, underline what you're trying to find in the question. What is it you're trying to discover? Third strategy, thought bubble mathematics, I call it, where you go off to the side and go, let's just do this with numbers for a second, so I get unconfused. Fourth strategy, a word equation. After I have that, here comes my word equation. I'm not trying to do algebra here. I'm just trying to describe what's going on. It says the sum of 2 squares of 2 consecutive integers is 452. So, sum. What does sum mean? Adding, right. So, word equation coming here. Not an algebra equation, a word equation. So, if I take the integer, first integer, and I've left something out, and I add the second integer, and I've left something out, stick with me, those are supposed to add up to 452. That's what's supposed to happen. I've left something out though. So I add a new strategy. Keep rereading the problem. Word problems are not the type of things you read once and go, yep, I'm good. As you build the algebra for it, you have to go back and reread it because I've left something out. I'm going to read it now and you tell me what I left out in my word equation. The sum of the squares of 2 consecutive integers is 452. So my word equation should have had first integer squared plus second integer squared. So what is a word equation? A word equation is where I use some words to describe what's going on here, as opposed to doing it all with algebra. And after all that, I'm now ready to write my algebraic equation that's going to help me solve this problem. What is the first integer? 52? No, it's not 52. 20? 17? 405? X is the first integer. That's why we went through those let statements. So at this moment when we had our word problem, we'd go back and go, oh, first integer, X. That's really hard for me. That's like my workout today, to be able to write that up there while I'm up here. Now, what's the second integer? X plus 2, okay? Hopefully some newfound respect for these let statements. Because if it was just this let statement you had to write in grade 7, and you're like, teacher takes a mark off when I write let statement, stupid let statements. That was not the game at all. The game is what the heck is going on here? So when you're reading a word problem, you're like, what is going on here? Your brace, your crutch, your helper is the let statements to get organized. So then this is x plus 2 squared equals 452. That's another phase of the problem completed. Most students are happy when that phase has been completed. They're like, that was the worst part. That's what I try to do on the quiz, right? I tried to give you the word, because I know the first time through word problems, it's not fair, I don't think, to just drop you on a quiz where you've got to come up with that stuff. So I got the lesson today where I do, let's do some more word problems. Will I just hand you the equation on the test always? No. Okay? And I'll talk about that as we get closer to the test. But I will use word problems you've seen before. If you look through the word problem, I'm not going to bring a word problem out of left field and throw it on the test. It's going to be one you've seen before. It's going to be the, what did I do on the quiz? The t-shirt, raising the price by 1. Or it's going to be one of the rectangle ones. The ones you've seen before. Okay, what was the third type there was a lot of in the homework? I don't know. Scary if you don't know. But what was the third type of word problem? There's some rectangles. There was some raise the price by a certain amount ones. And then there was some ones like this with consecutive integers or with integers or 2 times the integer or stuff like that. So get ready for those 3 types of word problems. And the ones I'm doing on the board here. Okay, into the algebraic phase. Into the algebraic phase. For most people, they're like, okay, now I can do some work here. X squared plus, let me just multiply out these brackets here. And I get x squared plus x squared plus 2x plus 2x plus 4 equals 452. I get 2x squared plus 4x plus 4 equals 452. All I did there was distribute the brackets. Did I do it right? 2x, 2x, 4? Yeah, I did. And collect like terms. I didn't do anything crazy there at all. Key moment in the algebra, though. Is this ready to solve? Let me rephrase. What's the next step to solving this quadratic? Complete the square will work. That is one possibility. Factoring will work. That is one possibility. Set it to 0. Okay, so all right answers. I could complete the square to find the vertex and solve it that way. I could factor it if it will factor. And there's a third way. Well, we'll get to that in just a second. But the most important thing is all those things work only if this is a 0 over here. It was all set up to be 0. Could we have gone back and taught this all so you could have a different number there? The answer is no, and it doesn't matter. What matters is we set everything up with 0 over there, so I'm going to bring that over. 2x squared plus 4x plus 4 minus 452 equals 0. And so I get 2x squared plus 4x minus 448 equals 0. Now, let's talk about the three strategies. I'm going to put them in a special bracket here to help you in your studying. Two of the methods have been mentioned. We could complete the square. We could factor. That will work if it factors. What's the third method from yesterday?
Quadratic formula.
You've now got the quadratic formula. Now let me ask this. Which one will be fastest and easiest if it works? Factoring is the one. Second, I think, is quadratic formula. If you've kept up with the homework, you're like, I'm not going to complete the square unless you force me to solve these. Yeah? And that's fair to think of it that way. So I'm going to try and factor this thing. What type of factoring comes first? Common factorings. This one, they're all even, so it all divides by 2. Now, two numbers that multiply to 224 but add to 2, you might give up at that point and go, I'm going to switch and do quadratic formula. But there's something about this question that tells me this must work. So I get my calculator out and I go, okay, multiplies to 224. 2 must work. 224 divided by 2. 2 and 1, 12. That's never going to add to 2. Yeah? 3. Does 224 divide by 3? No, it doesn't. Does 224 divide by 4? Yes, it does. 4 and 56. That's not going to add to 2, though. 16 and 14, somebody says? How did you get that fast? He knew 16 and 14 divided by 224. Somehow he knew. And sometimes you'll know. You'll be able to jump ahead and find something closer. In fact, the fact that these are so far away from each other tells me I'm not close to the answer. So maybe he jumped ahead and said, let me try 10. You know, 224 divided by 10, does that work? No. 224 divided by 11, does that work? No. 224 divided by 12? Oh, what was it? 224 divided by 12? That doesn't work. What did you say?
16 and 14.
Oh, I thought you said 12. 224 divided by 13? By the way, if you're out there thinking, I could have finished the quadratic formula by now. Yeah. Yeah, that's why it's there. Go ahead. If the numbers are too big or they're crazy decimals, you should do that. 224 divided by 14 is 16. Ooh, 14 and 16 works. So this is 2x plus 16, x minus 14 equals 0. Now I can answer the question. Therefore, x equals negative 16 or x equals 14. Two different answers? The quadratic goes, yeah, two different answers. It's a quadratic. We can get two different answers here. So I split this down the middle and I go, okay, if x is negative 16, that would be the first integer. First integer, negative 16. Or the first integer might be 14. Excuse me, 14. If the first integer is negative 16, how am I going to get the second integer? Sub it in. See, the let statements are even more powerful than I let on. The let statements go, here's what you do. After you've done all this algebra, you're like, what do I do? What do I do? It says add 2. Second integer, negative 16 plus 2, which is negative 14. And here's second integer, 14 plus 2, which is 16. So the two pairs, there's two pairs of numbers that will, their squares will add up to 452. Negative 16 and negative 14, positive 14 and positive 16. But you see why it happened? Because a negative times a negative is a positive. This squaring allowed there to be two different answers. The negatives will work, but the positives will work. That's one type of word problem that could appear on your test that you will have to come up with the equations. Is there going to be a million on there? No. There's not enough time on the test for me to ask 17 word problems. There won't be time because I got other questions I got to ask. But yeah, there could be one. And by test time, you should call me out. You say, Mr. Todd, how many word problems? Come on, tell us. Tell us how many word problems where we got to come up with the equation. And by then I'll have the test done and I'll go, this many, and then you'll know. Then you can make your guess. You go, I know that Mr. Todd. He certainly likes those number ones. I think it's a number type one. I'm going to make sure I'm ready for number type ones. Or maybe you go, oh no, he seems to like the rectangle ones. I'll make sure I'm ready for the rectangles. Or I'm ready for all three. Whatever you got. I saw the one in the quiz. Saw the number one again. Whichever one, yeah. But do you have any questions about that? I'm going to say the same things in the second one. I'm going to go a little faster to unbore you a little bit. I'm going to talk about the same strategies in the second one. I think. I don't know. I forget what the second word problem is, but I think it has a lot of the same strategies. Do you need more time there? I tried to chitter along there, so is it big enough, Hazel? Not really. Maybe I'll put some extra desks up here, and I'll put your guys' name on them. You can have temporary seating up in the front. There's a chemistry classroom at the university, at Wilfrid Laurier University. You wouldn't believe it you won't believe it when I tell you. It has individual sideways desks all the way around, all facing outwards. When you walk in, you're like, what's going on? But there were screens at every location. And the screens were interactive, which means if you went up to your screen and wrote something on there, it would appear on everybody else's screen so they could see it too. That was awesome. Mr. Todd did 2 of those number ones on that second lesson. I feel like that number one's going to be on there. The sum of 2 numbers is 30 and the product is 209. Find the numbers. After reading that and hearing my first example, what would you do next?
Underline find the number.
Find the numbers. That's the opposite order of what I said, but I like it. Find the numbers. How many numbers is there? 2. So let statements. Great start. And even if we accomplish nothing else, at least we're getting part marks for our let statements. Let x equal the first number. Mistake coming. Let y equal the second number. And hopefully you're noticing, oh, maybe he doesn't think that's a mistake. Maybe that's part of the process is writing out, okay, now I got a variable for each one. I wish there wasn't 2 variables. Then what would you do? Little thought bubble mathematics over here. And this is especially for people who are like, you know, algebra's not my thing. I don't like these x's. It really makes me nervous. You go over here and go, okay, forget about that. Go over here and go, just make up any number. I'm going to pick 10. If 10's the first number, what's the second number? See, no algebra. 20. How did you do that? See, that's the hard part. He goes 20, yes. But how did you get from 10 to 20? That's the hard part of the algebra, is going, how did you get from 10 to 20? Well, because 10 to 20 is 30. Yeah, I know, but we need to be able to do it algebraically. What do I do with 10 to get to 20? Add 10 is not right. It's not add 20, no. Let's do another one. If the first number was 5, what would the second number be? The sum of the 2 numbers is 30. 25. What am I doing here? Subtracted it from 30. 30 minus 10 equals 20. 30 minus 5 equals 25. That's not easy. I'm not acting like that's easy. I'm not saying thought bubble is going to be easy. But if you can't go over here and pick some number and figure out what the second number is, then you got no chance at the algebra. So that's what the thought bubble's for, is go over there and go, how do I get from the first number to the second number? You go 30 minus that number. I'll give it a little more here. Somebody else might go, you're making it too hard, Mr. Todd. X plus y equals 30. That's what's going on. Those 2 numbers add to 30. So now I can figure out why it's 30 minus x. And that is a good thinking as well. In calculus, that's how we usually think. We step past the thought bubble a little bit and go, I can use some algebra here to figure out what y is. And so I like that too. That's also out there. But either way, come back over here and go, no, not y. 30 minus x is the second number. That's how I get that second number. Now I'm ready. That phase of the question is over, and you can take a deep breath and go, oh, whew. Got the let statements now. The sum of two numbers is 30. Their product is 209.
11 and 19.
Product is 209. What does product mean? What can I do for you? What would you like? You get to be on the video.
I want to be on the video.
Oh.
But thank you.
Do you want to do a sales pitch for chemistry while you're here?
Hi, a lot of these friends are in my class. They know.
Oh.
Right?
What do you need?
Who the best of.
Calculator? Money? What?
No, a stack of marking I can't find.
Oh, why would you try to find
I'm
that?
trying to keep it a secret.
What does product mean?
Multiplication.
Multiplication. So that means x times 30 minus x has to come out to 209.
11 and 19.
He already knows the numbers. Let's see if we can prove those are the numbers, shall we? 30x minus x squared equals 209. Is this ready to try my three strategies, which I'm going to write down again in a second? I've got three strategies I could do this problem with. Is it ready? No, what number do we need on one side of this thing? For 0. We need a 0 over there. Yes? You haven't been so happy to see a 0 since you saw Kanye West presenting. No, okay. Listen, a little wisdom here. See that negative x squared there? You got your choice. You can move these over there and make 0 on the left side, or you can make 0 on the right side. A little wisdom, if it's negative x squared, move it over. So now I get 0 equals x squared minus 30x plus 209. Two numbers that multiply to 209, but add to negative 30?
19 and 11.
How did you do it?
I multiplied 19 by 11 to get 209.
But how did you choose 19 and 11? Like, some people need some help here on how you came up with
I
those.
started with 15 and 15, and that was too high, so then I broke it up.
He's doing it the opposite way as me. He's looking at the negative 30. I'm glad. I'm glad I quizzed you, because he looks at the 30 and goes, okay, well, what adds up to 30 here? 15 and 15 adds to 30. So could it be 15 and 15? 15 times 15 is 225. No, but it's close, and you start feeling better. So then you go, okay, what else adds to 30? 14 and 16. 14 and 16 doesn't multiply to 209, but it's getting closer. Then what? 13 and 17. 221. 12 and 18. 216. 11 and 19. Maybe you lose faith. And if you lose faith at this point, what would you do? Well, you'd use the quadratic formula. So let me write that underneath. Our choices are complete the square, factor, quadratic formula. Those are your three choices. Factoring is going to be the fastest if you can get it to work. You just got to do a little trial and error on your calculator. And then we found out it was x minus 11 and x minus 19. Therefore, x equals 11 or x equals 19. So there's two separate answers here. The first number could be x. No, could be x. The first number is 11. Second number, how do we get the second number? Literally tells us in my let statement. See, let statements are powerful. Is 30 minus 11 equals 19, and your brain explodes. Confetti going all over the floor. You're like, oh. There is two different sets of numbers, 11 and 19 and 19 and 11. You're like, those really aren't two different ones this time. Yeah, because it didn't come up with the second one. So then the other way, the first number could be 19. Second number, 30 minus 19 equals 11. So it's either mind-blowing or like stupid, depending on how you look at it. It's like, whoa, same numbers both ways. Or it's like, well, yeah, of course it is, or else math is broken. How am I doing on time? Got too chatty. I've over-explained, haven't I? When does the spell go? 35?
Yeah.
13 minutes. I'll be okay. What questions do you have about that? Oh, good. I'm great at word problems now. If LeBron showed up here and said, hey, watch me shoot a basketball, and he went, whoop, swish, you wouldn't go home and go, hey, I'm great at basketball. You go home and get the basketball. I'm not trying to say I'm the mathematical goat. I'm just trying to say, watching me do it is one thing. Now you got to go try it. More time there?
I'm better than LeBron.
What's that?
I'm better than LeBron.
You're better than LeBron?
Yeah.
At basketball?
Yeah.
Have you ever seen Nathan play? He has some
The fact that I don't even know that he does play tells me he's not better than LeBron.
That's crazy.
More time? Oh, good, a geometry one. A preliminary floor plan for a new house includes a rectangular dining room that measures 5 meters by 4 meters. The owner of the house says, no, I want a bigger dining room. Hi there. I don't know.
I think you might have like one. One pop tab. No.
0. We struck out again. Sorry. The customer wants a larger dining room. Okay, so the diagram's a little hard to understand here. This is the dining room. This is the current dining room right here. They want something bigger. They look at the house plan, they go, no, no, bigger. They want 25 meters squared. How big is it right now? Current is 4 times 5, which is 20. They want bigger. The architect says, no, okay, I can't do it. If I'm going to make it bigger, I got to make it bigger the same on both sides. I got to make this strip a little bit bigger. So I'm going to make it a little bit bigger here and a little bit bigger here. So my let x statement is the width of the new strip. Now, I think the geometry questions are easier. And I don't mean like as a teacher. I don't mean like Mr. Todd finds these easier. I mean, when I've seen math students in the past who've engaged with these questions and tried a few, they usually find the geometry ones the easiest ones. Because look at this. The new area will be length times width. Is everyone okay with area equals length times width? What's the length of this thing here? This whole length here? How long is it? 4 plus x. How wide is the new area, the new dining room? 5 plus x. And what do those two things have to multiply to? What did the homeowner want as their actual area? 25. I think you'll find, if you really engage with the geometry problems, you'll find those easier than the other ones. Those languagey ones, the sum of the squares of the, so if I were a betting person for the test, I'd go, I'm going to make sure I got the geometry. If he selects geometry, I want to be ready for that one. Because the other ones, they're not really my strength. Okay, but I'm not telling you, I'm not giving you a test hint, because I haven't wrote the test yet. You can work me over for a hint as we get closer. The rest of it, pretty straightforward. I'll get it down, not because I'm rushing, because you might be bored with these next steps here, and we'll talk about it, okay? Expand those brackets. Somebody was talking about this just before the quiz, right? Say, you got to expand the brackets first. Right? That was the part. I did it for you on the quiz, but on the test, it might be like, you got to expand those brackets first. Life's pretty good so far. What's the next important step? I'm going to write in blue. What has to happen next? I need 0 over here. Yeah, so this has to come over. And if you're drifting off to sleep, you might want to come back for just a second, because maybe the most important point of the lesson is coming right up in just a moment. Gentlemen, What two numbers multiply to -5 but add to 9?
I don't know. Decon.
No, it's just the one up front. It's just multiply negative. So here they are. 1, -5. 3, -3.
Oh, we're multiplying to 9.
Multiplying, oh, sorry, multiplying to 5. So 3 doesn't work. 1, -5 multiplies to -5. 2 doesn't work at all. 3 doesn't work at all. 4 doesn't work at all. I guess I could go -1, +5. There's no two numbers that multiply at -5 and add to 9. Quadratic formula. I'll do my dramatic thing to try to help you on the test. Here's me trying to help you on the test. Ready? Well, it doesn't factor. Whoa, careful. It doesn't factor. I wish there was a formula to solve quadratics like this. That's what the quadratic formula does. So in this one, we're stuck with the quadratic formula. X equals -b plus or minus b squared minus 4ac. And just in case you're like, I was studying for the quiz all last night. I didn't do any quadratic formula questions. Well, here it is again. -9 plus or minus square root 9 squared minus 4 times 1 times -5 over 2 times 1. X equals -9 plus or minus square root. Can I do it in my head? Is somebody getting their calculator ready, just in case I don't want to make a mistake on the video? Is 9 squared minus 4 times 1 times -5 equal to 101? I think it does. Now I'll prove this can be done with one of these piece of crap calculators.
That is right. That's correct. In my head.
-9 plus square root 101. On these type of calculators, then you'd press equals. Then divide by 2. 0.5. What did it say? Nearest thousandth. Did it say nearest thousandth? Or x equals -9 minus square root 101 equals, divided by 2, -9.52. Huh? We're adding on a piece and it says subtract a piece? I'll talk about that in a minute. For us, no. We were supposed to be adding pieces. Now just make sure you answer the question. What did the question say? How wide should the strip be? Therefore, the strip should be 0.525 meters. The negative does have meaning, though. If we instead went and subtracted off there, the room would be on the other side over there, so it would have negative length and width because it's out this side, and it would multiply out to be the right things. Don't worry about that too much. I just don't want you to think the negative just is completely meaningless. It's just not what we're looking for in this question. You've ran into that before, I think, where the negative answers we ignore. Yeah? Whew, I made it. But hey, what questions do you have on that?